Can you hear me? Good morning. I have recently been in the press for my thoughts on the future of humanity and the need for our generation to look to colonize outside Earth. I remain committed to this view. Allow me to explain further. A century ago, Einstein revolutionized our understanding of space, time, energy, and matter. We are still confirming his predictions today. As we all know, in 2016, LIGO caught the first distinct sounds of gravitational waves emitted by colliding black holes some 1.5 billion years ago. Einstein's genius was the ability to look behind the surface, to challenge accepted norms, and to forgo common sense. At the age of 16, he visualized riding on a beam of light, and saw that beam as a frozen wave. By digging down and challenging the perceptions of the time, this ultimately led to his theory of special relativity. Today, we physicists know far more about the universe than did Einstein. We have much better tools for discovery, such as particle accelerators, supercomputers, space telescopes, and constant experimentation. This is a wonderful time to be a scientist. We are riding Einstein's beam of light. But it is the human race's imagination that remains our most powerful attribute. With this, we can roam anywhere in space and time. And I do. We can witness nature's most exotic phenomena while in a car, snoozing in bed, or pretending to listen to someone boring at a party. And I do. Much of my own life has been spent exploring the nature of black holes, their geometry, evolution, and the fate of those unfortunates who happen to fall into them. Black holes continue to fascinate my imagination. Last year, Andy Strominger, Malcolm Perry, and I reimagined black holes, examining the energy state of their vacua and the information stored on their boundaries. This research will have potentially deep implications for physics. But what does this have to do with the future of humanity? Before I answer this, allow me to ask you a question. If our imagination, helped by data from all the scientific tools available to us today, can cross the universe, making discoveries along the way, why go anywhere for real? Shouldn't we be content to be cosmic sloths, enjoying the universe from the comfort of Earth? The answer is no. The Earth is under threat from so many areas that it is difficult for me to be positive. The threats are too big and too numerous. I believe the following are the main three. First, the Earth is becoming too small for us. Our physical resources are being drained at an alarming rate. We have given our planet the disastrous gift of climate change. Rising temperatures, reduction of the polar ice caps, deforestation, and decimation of animal species. We can be an ignorant and thinking lot. When we have reached similar crises in our history, there has usually been somewhere else to colonize. Columbus did it in 1492, when he discovered the New World. But now there is no New World. No utopia around the corner. We are running out of space, and the only places to go to are other worlds. It is time to explore other solar systems. Spreading out may be the only thing that saves us from ourselves. I am convinced that humans need to leave Earth. Second, the universe is a violent place. Stars engulf planets, supernovae fire lethal rays across space, black holes bump into each other, and asteroids hurtle around at hundreds of miles a second. Granted, these phenomena do not make space sound very inviting. Yet these are the very reasons why we should venture into space, instead of staying put. Because if we wait long enough, they will reach us here. This is not science fiction, it is guaranteed by the laws of physics and probability. To stay risks being annihilated. Third, we are by nature explorers. Motivated by curiosity. This is a uniquely human quality. It is this driven curiosity that sent explorers to prove the Earth is not flat. That is the same instinct that sends us to the stars at the speed of thought, urging us to go there in reality. And whenever we make a great new leap, such as the moon landings, we elevate humanity, bring people and nations together, usher in new discoveries and new technologies. To leave Earth demands a concerted global approach. Everyone should join in. We need to rekindle the excitement of the early days of space travel in the 60s. The technology is almost within our grasp. Spreading out into space will completely change the future of humanity. It may also determine whether we have any future at all. It won't solve any of our immediate problems on Earth, but it will give us a new perspective on them, and cause us to look outwards rather than inwards. I hope it would unite competitive nations in a single goal, to face the common challenge for us all. We have already walked on the moon, driven rovers on Mars, landed a probe on Titan, and Tim Peake worked for 6 months on the ISS. But this is long-term thinking. And by long-term, I mean hundreds, or even thousands of years. It won't be easy. Wherever we go, we will need to build a civilization. We will need to take the practical means of establishing a whole new ecosystem that will survive in an environment we know very little about. And we will, of course, need to consider transporting several thousands of people, animals, plants, fungi, bacteria, and insects. Maybe there are things we need and have not enough of. Whatever, it's a no-return journey. So which sites have the most potential? The most obvious is the moon. We could have a base there within 30 years. It is close by and relatively easy to reach. We have already landed on it and driven across it in a buggy. On the other hand, the moon is small and without atmosphere or a magnetic field to deflect the solar radiation particles, as on Earth. There is no liquid water, but there may be ice in the craters at the north and south poles. Travelers could use this as a source of oxygen, with power provided by nuclear energy or solar panels. It would mean that the moon could be a base for travel to the rest of the solar system. Mars is the next most obvious site, and we could reach it in 50 years. It once had a magnetic field, but it decayed 4 billion years ago, leaving Mars without protection from solar radiation. This stripped Mars of most of its atmosphere, leaving it with only 1% of the pressure of the Earth's atmosphere. But we can identify runoff channels and dried up lakes, even if liquid water cannot exist on Mars today. We can also identify caves, where the carbon dioxide ice has been pushed down into a hole, made by a meteor. Mars had potential, but if we find evidence that life had once existed, it would indicate that the probability of life developing on a suitable planet is fairly high. The Moon and Mars have potential. But what about boldly going beyond the solar system? Take Proxima b, for example. This exoplanet, which is the closest to Earth, but still 4.5 light years away, orbits the star Proxima Centauri. Recent research indicates that it has some similarities to Earth. our observations indicate that a significant fraction of stars have planets around them. So far, we can detect only giant planets such as Jupiter and Saturn, but it is reasonable to assume that they will be accompanied by smaller, Earth-like planets. Some of these will lie in the Goldilocks zone, where the distance from the star is in the right range for liquid water to exist on their surface. There are around 1,000 stars within 30 light years of Earth. Even if only 1% of these have Earth-sized planets, we have 10 candidate new worlds. Traveling to these isn't possible with today's technology, but by using our imagination, we can make interstellar travel a long-term aim in the next 200 to 500 years. The speed at which we can send a rocket is governed by two things: the speed of the exhaust and the fraction of its mass that the rocket loses as it accelerates. The exhaust speed of chemical rockets, like the ones we have used so far, is about 3 kilometers per second. By jettisoning 30% of its mass, they can achieve a speed of about half a kilometer per second, and then slow down again. According to NASA, it would take as little as 260 days to reach Mars, give or take 10 days, with some NASA scientists predicting as little as 130 days. But it would take 3 million years to get to the nearest star system. To go faster would require a much higher exhaust speed than chemical rockets can provide, that of light itself. A powerful beam of light from the rear could drive the spaceship forward. Nuclear fusion could provide 1% of the spaceship's mass energy, which would accelerate it to 1/10 of the speed of light. Beyond that, we would need either matter-antimatter annihilation, or some completely new form of energy. In fact, the distance to Alpha Centauri is so great that to reach it in a human lifetime, a spacecraft would have to carry fuel with roughly the mass of all the stars in the galaxy. In other words, with current technology, interstellar travel is utterly impractical. Alpha Centauri can never become a holiday destination. We have a chance to change that, thanks to imagination and ingenuity. Last year, I joined with Yuri Milner to launch Breakthrough Starshot, a long-term research and development program aimed at making interstellar travel a reality. If we succeed, we will send a probe to Alpha Centauri within the lifetime of some of you here today. But I will return to this shortly. How do we start this journey? So far, our explorations have been limited to our local cosmic neighborhood. 40 years on, our most intrepid explorer, Voyager, has just made it to interstellar space. Its speed, 11 miles a second, means it would take about 70,000 years to reach Alpha Centauri. This constellation is 4.37 light years away, 25 trillion miles. If there are beings alive on Alpha Centauri today, they remain blissfully ignorant of the rise of Donald Trump. For 4 years, Kennedy permitted the United States to landing a man on the moon by the end of the 60s. He did it, just. Some of us here today can remember the excitement of the moon landing in 1969. To stimulate a similar enthusiasm for a new generation familiar with modern technology and the potential it offers, a new manned space flight program is the answer. For the successful future of humanity, we have to go out into space ourselves. I had always dreamed of space flight. But I thought that with my limitations, it would remain a dream, and I would never get to experience the wonders of space, except through mind travel, imagination, and my work in theoretical physics. But I had not factored in the energy and enthusiasm of individuals, whose mission it is to take that first step in venturing outside Earth. And in 2007, I was lucky to experience a total of 4 minutes of weightlessness in zero gravity. I am quoted at the time, 10 years ago, that I feared the human race is not going to have a future if we don't go into space. I believed it then, and I believe it still. And I hope I demonstrated then that anyone can take part in space travel. I believe it is up to scientists like me, together with innovative commercial entrepreneurs, to do all we can to promote the excitement and wonder of space travel. One of those entrepreneurs is Richard Branson. He has the vision and persistence to open up space flight to Earthbound citizens. It is now common knowledge that I confessed to him that it was my ultimate ambition to fly into space, but I thought no one would take me seriously. He immediately offered me a seat, and I immediately accepted. Since then, I have never changed my mind. It is clear we are entering a new space age. The first private astronauts will be pioneers, and the first flights will be hugely expensive. But over time, it is my hope that space flight will become within the reach of far more of the Earth's population. Taking more and more passengers into space will bring new meaning to our place on Earth and to our responsibilities as its stewards. It will help us to recognize our place and future in the cosmos, which is where I believe our ultimate destiny lies. There are those who would argue that it would be better to spend our money on solving the problems of this planet rather than wasting it on a possibly fruitless search for a new planet. I am not denying the importance of fighting climate change and global warming. Unlike Donald Trump, who may just have taken the most serious and wrong decision on climate change this world has seen, I am arguing for the future of humanity and a long-term strategy to achieve this. A goal of a base on the moon by 2020 and a manned landing on Mars by 2025 would reignite the space program and give it a sense of purpose, in the same way that President Kennedy's target did in the 60s. The spin-off to this would be an increase in the public recognition of science generally. It seems we live in an era in which science and scientists are in danger of being held in low and decreasing esteem. And this could have serious consequences. Today's society is increasingly governed by science and technology, yet fewer young people seem to want to take up science. A new and ambitious space program would excite them and stimulate interest in other areas, such as astrophysics and cosmology. There are risks, of course. What will we find when we go into space? Is alien life out there, or are we alone in the universe? If we believe that life arose spontaneously on Earth, it must also be possible for life to appear on other suitable planets. But even if the probability of life appearing on a suitable planet is very small, it is logical to assume that since the universe is infinite, life will have appeared somewhere. But we don't yet know how life evolved on Earth. It could have been the random collision of simple macromolecules, which evolved into DNA, or it could be by panspermia, the spreading of life from planet to planet, carried by meteors. My advice to you is to be careful if you meet an alien. You won't know where it has been. More seriously, I believe there are 3 reasons why we haven't yet heard from aliens. First, it may be that the probability of primitive life appearing on a suitable planet is very low. Second, even if the probability of primitive life is reasonably high, the probability of that life developing intelligence like ours may be very low. And third, it could be that alien life develops into a fully functioning civilization, but it then destroys itself with war, disease, and weapons of mass destruction. I believe this is the trajectory we are on. Personally, I prefer the second reason, that primitive life is relatively common, but that intelligent life is very rare. Some would say it has yet to occur on Earth. Another risk to our exploration of space for human colonization is our lack of knowledge concerning how long we may be able to survive. recent experience with the ISS shows that it is possible for human beings to survive for many months away from Earth. However, the zero gravity of orbit causes a number of undesirable physiological changes, and weakening of the bones, as well as creating practical problems with liquids, etc. Remember, this is a one-way journey. There is no returning to Earth after a few months or years. However, we have a chance. As I mentioned earlier, Breakthrough Starshot is a real opportunity for man to make early forays into outer space, with a view to probing and weighing the possibilities of colonization. It is a proof of concept mission, and works on three concepts: miniaturized spacecraft, light propulsion, and phase-locked lasers. The Starship, a fully functional space probe, reduced to a few centimeters in size, will be attached to a light sail. Made from metamaterials, the light sail weighs no more than a few grams. It is envisaged that 1,000 starships and light sails, the nanocraft, will be sent into orbit. On the ground, an array of lasers at the kilometer scale will combine into a single very powerful light beam. The beam is fired through the atmosphere, striking the sails in space with tens of gigawatts of power. The idea behind this innovation is that the nanocraft ride, as did Einstein, on the light beam. Not quite to the speed of light, but to a fifth of it, or 100 million miles an hour. Such a system could reach Mars in less than an hour, reach Pluto in days, pass Voyager in under a week, and reach Alpha Centauri in just over 20 years. Once there, the nanocraft could image any planets discovered in the system, test for magnetic fields and organic molecules, and send the data back to Earth in another laser beam. This tiny signal would be received by the same array of dishes that were used to transit the launch beam, and return is estimated to take about 4 light years. Importantly, the Starship's trajectories may include a flyby of Proxima b, the Earth-sized planet that is in the habitable zone of its host star, in Alpha Centauri. Only this year, Breakthrough and the European Southern Observatory joined forces to further a search for habitable planets in Alpha Centauri. There are secondary targets for Breakthrough Starshot. It would explore the solar system and detect Earth-crossing asteroids. In addition, the German physicist Claudius Gross has proposed that this technology may also be used to establish a biosphere of unicellular microbes on otherwise only transiently habitable exoplanets. So far, so possible. However, there are major challenges. A laser with a gigawatt of power would provide only a few newtons of thrust. But the nanocraft compensates for this by having a mass of only a few grams. The engineering challenges are immense. The nanocraft must survive extreme acceleration, cold, vacuum, and protons, as well as collisions with junk, such as space dust. In addition, focusing a set of lasers, totaling 100 gigawatts on the solar sails, will be difficult due to atmospheric turbulence. How do we combine hundreds of lasers through the motion of the atmosphere? How do we propel the nanocraft without incinerating them? And how do we aim them in the right direction? Then we would need to keep the nanocraft functioning for 20 years in the frozen void, so they can send back signals across 4 light years. But these are engineering problems, and engineers' challenges tend, eventually, to be solved. As it progresses into a mature technology, other exciting missions can be envisaged. Even with less powerful laser arrays, journey times to other planets, the outer solar system, or interstellar space, could be vastly reduced. Of course, this would not be human interstellar travel. Even if it could be scaled up to a crewed vessel, it would be unable to stop. But it would be the moment when human culture goes interstellar, when we finally reach out into the galaxy. And if Breakthrough Starshot should send back images of a habitable planet orbiting our closest neighbor, it could be of immense importance to the future of humanity. In conclusion, I return to Einstein. If we find a planet in the Alpha Centauri system, its image, captured by a camera traveling at a fifth of light speed, will be slightly distorted, due to the effects of special relativity. It would be the first time a spacecraft has flown fast enough to see such effects. In fact, Einstein's theory is central to the whole mission. Without it, we would have neither lasers, nor the ability to perform the calculations necessary for guidance, imaging, and data transmission over 25 trillion miles, at a fifth of light speed. We can see a pathway between that 16-year-old boy, dreaming of riding on a light beam, and our own dream, which we are planning to become a reality, of riding our own light beam to the stars. We are standing at the threshold of a new era. Human colonization on other planets is no longer science fiction. It can be science fact. The human race has existed as a separate species for about 2 million years. Civilization began about 10,000 years ago, and the rate of development has been steadily increasing. If humanity is to continue for another million years, our future lies in boldly going where no one else has gone before. I hope for the best. I have to. We have no other option. Thank you for listening.